Hey,
Hey
how's it
Magenta,
going?
going pretty well. How about you?
All right, super excited to have Kat from Field Ready joining us and Mayulin, who used to work in the field. And I'll let them introduce themselves and tell you a little bit about their background and expertise, and then we'll get started on your projects. Like I said, we had the links to your projects in advance, so we were able to take a brief look, and we'll be able to look at them as we talk too. So go ahead, Kat, if you want to introduce yourself.
I am an engineer for Field Ready. I started recently in late March, and I was hired to be a field engineer at our Pacific office, but coronavirus had other plans for me, so I've actually been stuck in the States the entire time I've been working for Field Ready. So I'm kind of filling in weird little gaps that I can help with remote. So hopefully, fingers crossed, I make it to Fiji at some point. My experience prior to this was I was a research and development engineer at a medical device company, kind of working on feasibility and early stage prototyping, rapid prototyping, and lab testing. And I have some experience working in makerspaces as well.
Thanks, Kat. Go ahead, Marianne.
My name is Marjolein. I'm from the Netherlands, and I used to work with Field Ready. I did my graduate internship for my bachelor in Nepal with the field office there. And I kind of started the whole fluid warmer project. So I was working in Nepal with this hospital called Annapurna Neurological Institute. And I was looking for a project to write my thesis about, and they had this really dodgy device laying in the office of the biomedical engineers, and I asked what it was, and it was a fluid warmer. So that kind of got the project started. So I wrote my bachelor thesis about the fluid warmer, how to make one low cost, as my bachelor was industrial design and engineering. Since then, I finished my internship with Field Ready, worked for them for a couple more months in Nepal, and then started a master's degree in development and rural innovation, which is kind of it's not really engineering anymore, but it's kind of the social science behind engineering. So why do we need these products? How do we see if people actually need them or not? How can we gauge if they're successful or not? So I'm at the moment finishing up my master's thesis on a new water system in rural Uganda to see if that was a good fit or not. So that's a little bit about me.
Great, thank you. So excited to have you guys here. And we have Audrey, who's working on the UV challenge, and then John, who's working on the fluid warmer challenge. So we'll get to cover a few different things today. So Audrey, if you're down to start, and if you could give a sort of quick 1 to 2 minute introduction to your project, and then if you had questions prepared, it'd be great to start with those, and then we can move forward with general feedback after that. And we'll stick with the 10 minutes per person for now, and then leave the extra time. If the third member doesn't join us, we'll have that at the end to come back to everyone. So take it away, Audrey.
So I made this collapsible UV LED lamp because I am a printmaker and I started out as a photographer. So I am innately interested in the image making process and how I can do that more affordably to scale, and from the fifth story building of my downtown Los Angeles studio, which means if I was to make cyanotypes the traditional way, I would have to go down carry my big loads of fabric down 5 flights of stairs, and then go expose it in the sun for 15-20 minutes, and then lug everything back up. So that's a little bit hard in a studio setting. So what I decided to do is bring the sun inside, or to the best of my ability, by using these UV LED lights. Again, I have a teeny tiny studio in downtown Los Angeles, which means space is key. So I wanted to make a lamp that was collapsible. So what I ended up using was this Mylar insulation fabric, which I learned about in my past as helping people build temporary structures, and how useful this can be for creating heat-proof and flexible, but potentially rigid backing for the LED light. So I used this material and then created a way to adhere the LEDs, and then wired everything up, did some cable management, and then you don't have to watch the video, but what I was able to do with this UV panel was create a PVC frame and just use A-clamps to adhere the light panel to the frame, and then I basically, everything under here becomes my a distance for my exposure unit. So I'm gonna grab something really fast. I was able to make the fabric for this reupholstered chair using this technique. And when the Hackaday Prize became viable, or came online for this year, and there was a UV challenge, one of the things that I had mentioned initially in my project that I had gel nails on and they glowed under the light, and so I was like, oh, of course this could be used to cure UV resin. And so this is just like I think maybe $30 in parts that could be repurposed and deployed really easily. Yeah. How's that? I think that's time for 2 minutes.
Yeah, that's great. Did you have any specific questions you wanted to start out with?
Yeah, one of the things, so with the UV curing challenge, I haven't demonstrated that in my project because it was really truly not the intent for me. But in understanding what the challenge is more, do you think it would be valuable for me to like get my hands on some UV resin, or even do my nails under it to try and like present this or a different configuration? And UV curing resin is I work with lots of epoxies and adhesive for work, but I've never used that, and so like it would definitely have to take a little bit of experimentation for me to present that on this project page as well.
Yeah, I mean, I think it would definitely be make the page a little more competitive if you were able to demonstrate the application. And I think, like you said, you could do it with a few different examples, whether it's like a 2-part adhesive that needs UV, or a 3D print if you have a 3D printer, or well, you'd have to have specifically a resin 3D printer. So I don't know if you do, but or the gel nail idea. I think you could definitely get creative with any of those. But I definitely think the application would help the judges to see exactly how this applies to the challenge. I don't know if Kat has any ideas around that as well.
Yeah, I have some ideas. I think, well, one, I think this is a really cool project. I think the idea of like a collapsible, like I could see this being really useful for you and your exposures. I think it's really cool that you built something like specific to your need. I could see it being a really useful like grow light for plants, or possibly for sterilizing things. I'm not sold on kind of like this kind of light from one direction box scheme for UV curing. My experience with UV curing is this wouldn't be terribly useful, but I don't want to take that away from, I think this is a really cool project, really great work. I think could even be really cool. I mean, going back to like what this was initially made for, if your frame was collapsible too, because I noticed your PVC frame is like 3D.
It is collapsible. It
does.
Yeah.
Oh, okay, you didn't cement it. That's good.
Yeah.
I was thinking it was like
temporary screw-in joints instead.
But like if you Google kind of your standard UV cure setups with the wand is really useful, because if you're curing like UV cure is often used to make fluid tight barriers. So you'll be sealing like a tube into a hole. And so you put the cure on, you put the tube in, and then it's nice to be able to move the wand around and to have a bit of like a directed, concentrated source of light. The other thing is with so much UV light, to actually like work under it, you would need to like have your object and your hands. But it is actually I mean, there's a reason we wear sunscreen. You don't really want to be exposing your skin to that much UV. And the way that's set up too is I think there's a lot of diffuse UV light coming out. So I mean, for your sake, you should make sure you're wearing UV safety glasses. I think all to say, however, I think there are like specific objects where something like this could be really useful. Like if you were UV curing kind of the same thing again and again, and it's like a flat sheet onto something else, and you really only need the light to come from one direction, like this could be really useful. But typically when I'm UV curing, I'm like moving a wand around to like lots of different spots because it's kind of like weird shaped objects.
Because the material is flexible, do you like if I presented this in a way that like showed it arching or like circling an object, that would be beneficial to?
Yeah,
because
I mean,
it's totally malleable.
Maybe start brainstorming like, yeah, how do you like take your kind of like, yeah, I guess your flexible thing. I would definitely test it on UV cures too, because I'm wondering like what the exposure times would need to be for this, just because I know those wands are so concentrated in UV light. So I think some testing of with this more diffuse setup, how long does it take? And what else was I gonna say? Oh yeah, do you know, like, have you thought there's you know, like UV encompasses a pretty wide span of wavelengths, so I'm not sure how the kind of like peak wavelength that you're using in your setup compares to like the ideal peak wavelength for resin curing.
The spec sheet on the LEDs that I used say that it's approved for UV curing but not sanitation.
Oh, okay, that's good. Yeah, I guess maybe if I were I think some good next steps could be like buy some resin and kind of try a bunch of different curing a bunch of different weird shaped objects to each other that you don't care about because they'll be scrapped afterwards, and see like what's it like to try to manipulate your soft like kind of fabric-y thing around it. And I think there's something to this, to your project. Like I can see it being really useful in a situation where you're like, let's say we're trying to do a production run of like several hundred items that are all going to have a UV cure element. Then I could see how you could like build a jig and set up your flexible Mylar thing in the perfect shape, and you just kind of like take your object and you drop it down, get secured, take it out. I see it having maybe less utility for like in the lab prototyping, because if you're just like prototyping one thing that has a specific shape and then the next thing you do is like a totally different shape, so but that's not a bad thing. I think but I think once you get to playing around with like actually trying to get it to work on a bunch of different kind of types of objects, you will get a feel for like where could this be useful, where might this not be useful. And I think this is all speculation. Maybe I'm wrong, and maybe it will be really great for prototyping as well. But if it does turn out that it's more like very useful when you can set it up in a jig and like leave it and use it for a bunch, like I think that's okay. And I think that can just become part of your documentation, and maybe some of your brainstorming can be like thinking about like a flexible fixturing that would let you like very easily kind of like form this
like armature wire or something.
Yeah, or something that's got like, you know, like bedside reading lamps. You can like take the lamp and move them like all over the place, you know, something with those sorts of like linkages or mechanisms. I don't know exactly what it would look like, but I think you'll start having ideas once you start playing with it, if you have the time and desire. But I think separate from this challenge too, like you could make a cool post about this being a really great grow light too. Grow lights are expensive, and not just for like for vegetables too. I got really into vegetable hydroponic gardening the last couple of years, and it's there's utility out there for I think there's more and more people trying to like grow food for themselves in like small living situations, or even people who are in like low light environments and doing their seed starters, and grow lights can get pretty expensive. So, and something about the flexibility of it, and if you had a really nice like adjustable stand, you know, as the plants grow, you can bump them up and etc. I don't know.
I think proving it out as the cure, if you're able to get to that stage, you know, like we said, would be great. And then I think being able to sort of show the variety of applications you might be able, like really selling the flexibility part of it, because I think that is what's a really strong component of your design, is that like, you know, you could, I don't know when there would be a need necessarily to make a really large cure lamp for something, but maybe there's a long joint you're trying to connect, I don't know, but really just showing the versatility of it, maybe of the size and the flexibility of the shape. And like you said, if you could wrap it around, you know, as a tube around something, but testing as much as you can each of those examples.
For your personal use currently, and also for this, I think you should also consider blocking off.
Yeah, you should see the elaborate little hut that I build.
Okay, cool. Yeah.
Kat's worried about your health. She's
these like 4x6 foam core sheets that like make it a zone.
Yeah, good. I know even with the wands, I had coworkers who, after like spending hours building up prototypes with the UV Cure and UV Cure wand, like will have like sunburnt their hands.
Yeah.
So.
All right, just in the interest of time, I think we should go to John's project. But I have some ideas around also just your page layout and stuff that I'll mention at the end, so remind me if I forget. Just that are general things we've sort of been saying to everyone about how to organize logs and things to optimize for the prize entry. So we'll go to John L, and then John O, you'll be the last 10 minutes.
Okay, I'm not familiar with how to like pull the project on. Are you able to do that?
Sure, I can share your project. So if you want to start with your 1 to 2 minute spiel and then elevator pitch, and then if you had any specific questions.
One of my projects for this year's Supply Frame Hackaday Prize is the I-beam warming pod, and it is for the Field Ready challenge. So I wasn't too familiar with the whole field, with the whole IV warming, so I had to do a little digging into it. So did some research in like what currently is being done, and yeah, like all the current solutions are quite complicated. Some of them actually have heating elements that come in direct contact with the fluid. So to keep this simple, cheap, and sanitary, I decided to go with a way of heating it without actually coming into contact with the IV, because then there's other health safety concerns that you would need to consider for that. So the design is very simple. It uses a 18650 battery, which is a very common battery. It's rechargeable, but it can be plugged in and can draw current directly from a USB port, although it wouldn't be able to draw as much as it directly from the battery. Each pod did a simple calculation. I'm actually not quite sure of how big IV bags are. Are they like 500 milliliters or?
They're I think it's like 250 to 350. is typical?
Okay, so yeah, the calculations that I did, an online calculator, my background is mechanical engineering, so I know a little bit about heat transfer, but I haven't done something like this in a while. But I used one of those online calculators for like a 500 milliliter IV. 10 watts would be enough to warm something up to human body temperature from 40 degrees Celsius. So one pod would be able to do that because a 18650 battery has about a 10 watt output, assuming it's 100% efficient. So the way that it uses resistive heating to heat up the later stage. So if you could scroll down a little bit, yeah. So it uses resistive heating to heat up the tube at the end, but it's also wrapped around the battery because when you draw current from the battery, it also heats up. It's not as much because the resistance of a 18650 battery is very low, but it does heat up. So it's just a way of trapping more of that heat into putting it into heating the IV fluid. And wrapping it around gives it a long transfer rate, a long enough time for it to dissipate the heat into the IV fluid. So yeah, so it's simple to use. It uses it's based off an Adafruit feather IC, so I have the schematic, if you could scroll down to that. So it uses an Adafruit feather IC with, up a little bit, and a USB charger that has a load sharing, so it can be plugged in to provide continuous power. I haven't worked on any of the software yet because I haven't built it yet, but this is just a concept at this point. Yeah.
Did you have specific questions you wanted to start with, or do you want us to just jump in?
Yeah, sure. What was your time? So I wasn't too, I saw the what was provided for the Field Ready Challenge, but what was your time frame on implementation? Like, because you said that you did some. This was part of a research project. Sorry.
I guess that the question is directed at me. I'm not too sure on the timeline that Field Ready has to implement this in the field, mainly because it takes really extensive testing for something to be able to be used. This is not strictly like something, it would take a lot longer if you would directly heat the blood like outside of the IV line. So right. This makes the implementation time a lot shorter. But I think for medical devices, I think Catherine can maybe tell a little bit more about how long like these testing phases last when you're doing this like at a company who specializes in this.
Yeah, sorry. Is your question about how long is acceptable for the blood to heat up in terms of like flow rate through your tube, or is your question about like medical device development?
It's for medical devices. So I did so I used to help out with getting FDA approval for medical devices. I know it's a very labor-intensive process, and for something like this, when you're heating up a IV fluid, it has to be pretty controlled.
Yeah, definitely. You can definitely kill a person if you do this wrong. So, yeah, the whole idea with this project is we don't have like we're going to take the best solution of this and have this in the field working for like 6 months from now. The idea with this is it was a compelling project that Mariahs started. There is a demonstrated need in many different geographies all over the world. But it's not a priority for us. Like no one internally was working on this because we don't have this timeline of like, this is a thing we want to be implementing in the field. I think that the best solution from this can be, depending on how good it is, could be a jumping off point to getting into more serious medical devices. Currently, we don't do anything that is of this kind of consequence in terms of medical devices. Most of what we're doing now, I'd say, is even we don't even do that much in the medical sector, where we do more with wash and other sectors. So this is kind of more of like a bit of a blue sky innovation, where it's like, wouldn't it be cool if we could do this? So what it would look like is we'd be like, this is a really cool project, and then we have kind of a couple of organizations that we've got pretty formalized partnerships and working agreements with that do have more experience in implementing high consequence medical devices in various geographies. So I think the next step would be taking it to them and being like, okay, let's make a plan for how we would actually do this in a safe way. But it would end up being a pretty lengthy process. And
one of the reasons I could see, because I'm picking apart this project, using a microcontroller kind of adds to the complexity of it. So maybe one possibility would be to do this off of, my background's mechanical, but I do a little electrical, like do this analog with op amps and control units that way, because I think the validation process would go a lot quicker, because I know validating the software and how reliable the software is would be a pretty difficult thing to do.
Yeah, definitely. Yeah, this is again one of those things where I mean, I wouldn't. Yeah, there's gonna be a lot of question marks and a lot of work to be done after this challenge closes if we are to ever actually distribute and manufacture these. But we do think it's a compelling enough prospect to be able to deliver something like this to run the challenge. But yeah, there's gonna be validation and verification issues, and just given our model of local and distributed manufacturing too, there's everything that comes into play in terms of making sure that the production facility has good QA and is up to snuff. So I'm not an electrics expert at all, and worked at a medical device company, but I wasn't. I was there for 3 years, but since I was on the feasibility early stage prototyping stuff, I was never deeply involved in the FDA work side of things. But I would say that if you, I think an analog approach from the case you just laid out seems like it could be worth looking at. Simplicity is definitely something we value.
Because with microcontrollers, they work pretty reliably, but for the medical industry, they want it to work in extreme conditions.
Yeah, and I mean, like a lot of medical devices do run off microcontrollers, but the verification for it's crazy, and the software is also
so
a huge thing.
That's why when I worked for a medical device validation company, a lot of the designs were overly, I always looked at them as like being overly complicated. Oh, you could use a microcontroller for this, but no, it's actually in their benefit to keep it analog.
Mm-hmm.
Okay, so one of the other questions I have is this project limited to a nonprofit, or would you consider commercialization of it? And the reason I ask is because IVs have become pretty popular lately, like kind of a boutique thing. People getting like IV drips down here in South Florida, like everyone's advertising on billboards everywhere. I don't know if that's what's going on in other areas, California, New York, but is that something that Field Ready would be interested in, or?
Probably not. I am just an engineer, but I have had conversations with our founder about kind of the structure of Field Ready and kind of social enterprisey like profit models are very popular. He doesn't actually. This is a longer conversation. We're limited on time, so I don't want to. I'll just leave it at probably not.
Okay.
Yeah.
Did you have any other questions, John?
No, we already, the last one was safety, but we kind of already talked about that.
Okay, so we have 3 minutes if Kat and Mariahs want to jump in on anything else based on what you've seen on the page, or?
I'll give my time to Mariahs because she knows more about this.
Okay.
Could you maybe scroll up a little bit to like the render of, yeah. So yeah, this is perfect. I really like how the two of them are stackable, that you can use maybe two on one IV line.
Yeah.
Because yeah, what I found when I did like a lot of the testing is that even though I made all these huge calculations about like warming the fluid within the IV line, it just never was the same in real life. It was always a lot colder than I thought it would be. That's why I really like the stackability.
Yeah, and that's going to be due to heat dissipation. So even though they're exposed right now, most likely they're going to have some kind of insulation cover on them.
So when you try to wrap it around something flat, it either won't like sit flush or will start to kink.
Okay.
And
okay.
yeah, and the kinks in IV lines, because they're already pretty thin, like it completely like stops the flow entirely.
Oh, no, you're right. Something I was considering doing, but I just for simplicity of time and wanted to keep the board exposed. But putting like a half spherical like aluminum block on there, copper block might work.
Yeah, I really think that would be a great idea, because yeah, I tested it myself with like kind of like a zigzag pattern over a heating element, and if I didn't get the angles just right, the IP line would kink every time and it would ruin the whole experiment I was doing. So I definitely think your idea has really great potential. I really like how simple it is, because that really is very important. Especially something I would say is very important as well is how user-friendly it is, because the people we were working with in Nepal, where is one of the places it could be implemented, it was just the simpler it is to use for the people who are using it.
Yeah, so the way I anticipated it be implemented is it's no set, like you don't set the temperature. It just assumes it needs to get the temperature up to 96 degrees or whatever it needs to get up to. The challenge with this project is to make sure that there's no like concentration of heat, because you don't want to heat up any part of the fluid too hot, because it might damage whatever the blood, it might damage any of the electrolytes that are in it. So yeah, dissipating the heat with like copper or like heat tubes might be a good way of going about it. But and you know, like I said, I did the calculations. This battery is barely capable of heating it up to the correct temperature. That's why we did the whole stackable thing, just in case it didn't get it up to the temperature. And so yeah, there would just be one button, it would turn it on, and it would work. I thought about putting like an LCD screen in it, but I thought that would complicate it a little bit too much. Maybe just like LED, like I think on the back there's an LED indicator that the temperature is good, and that would be.
Yeah, I think one of the FDA rules is that there has to be a warning indicator. So definitely, if you have an LED that could turn red, maybe,
right.
Like a little, and I think it needed to have more than one warning system. So maybe an LED and just like a little speaker that can like start beeping if it gets.
Okay. So no, audio would probably be better, yeah, since.
I would suggest both though.
I'm sorry, I'll have to cut you all off so we can make sure we have enough time for John O, but we should have a few minutes at the end to circle back, and I have a feeling that some of these questions might come up with John O's project too, potentially, so we might be able to continue the convo there. All right, sorry about that. Thank you, John L.
I was hoping I could just, is it Marjolaine? Is that correct?
Marjolaine.
But it's a very difficult Dutch name. Don't blame me.
Okay. I was hoping I could just ask you a couple questions about what you did, because it seems like you've got some real testing experience on this.
Yeah, I can give a little bit of a small rundown. So I worked with Field Ready for 8 months. 4 of those months were basically doing this project. So I worked full-time on this as my graduate internship for my bachelor degree in industrial design and engineering, with went more specifically into like medical stuff. And what I did is I went to a hospital in Nepal. Because I was working there at the time, and we found this really sketchy thing on the desk of a biomedical engineer, which turned out to be a fluid warmer, which they were developing. And we basically thought this could be a really good project to work on. And so basically I did a lot of research on fluid warmers, how they work, what kind of approval you need to get fluid warmers made. And then I started making my own. So I made a 3D printed case with a Arduino powered heating.
Are you able to share maybe some of the details of that research study?
I think that's a
form
little
of paper or report?
To Kat and Magenta how much they wanted to share.
Yeah, the report is available, so I'll send you the direct link to that. And
yeah, that'd be fantastic.
Yeah.
So just quick, what power heaters were you using?
Honestly, it's been 2 years. I can't remember. It's in the reports.
Okay, sounds good. Do you know what? Do you remember at all what kind of temperature rise you were able to get in the fluid?
I was only able to get a temperature rise because the blood is always kept like between 0 and like 4 degrees Celsius. Mm-hmm. I was only able to get it to warm up in my device once up to like 34 degrees, which was pretty hot. And after that, I never managed to heat it up that much again. I think that could be to do with like the environment that day. It was kind of hot out. It was in Nepal. It could have been a lot of things, but I never really got it to heat up that much, like 34 degrees Celsius again. So that was kind of where my 4 months ended, and I had to, hand it in.
All right. Yeah, appreciate it. I'm hoping I can learn some more from your report. It'll be an interesting read. I'll just give you kind of brief overview. Like John, I'm working on this IV fluid warmer project. My approach right now is just really trying to understand what the problem is. I've got some parts on the way for my first prototype. Kind of transitioned 3 or 4 times already. Trying to address that problem that Marjolaine and John are kind of running into is how do you get efficient heat transfer from your heater element to the fluid. So I think I've found a fairly low cost approach that might seem promising. I'm hoping to put it together and do some testing here in the next couple of weeks. So that's kind of where I'm at right now. Knowing that this can be a life-critical medical device, I've tried to learn as much as I can on what common industry practices are for maybe like fault detection and user alert systems that are typical on these IV fluid warmers. If anyone knows of like the relevant FDA standards that are typically followed in industry, that'd be really helpful to know. Other things that might be helpful to know are what is the target application for the fluid warmer, right? So what I've seen is fluid warmers that are designed for out in the field for traumatic injuries in combat zones. And those, right, are typically higher flow rate requirements. And so as a consequence, that requires a system that has better heat transfer efficiency, which is generally more expensive to develop. But if this is going to be used day in, day out at like a hospital, that those flow rates generally aren't required, maybe unless it's some kind of trauma imagery where they just need to get some blood to people really quick. So those are two different, in my mind, those are two different applications. And you can just kind of separate it out with the IV forms, like, is it high flow or is it a low flow? So if you guys give me any kind of clarifications on maybe which application you think is most relevant for this field ready challenge, I think that would be, it's certainly going to like set the stage for how I develop it to understand. Right now I'm targeting the high flow because if you can do the high flow, you can do the low flow too, but just kind of curious on what your thoughts are there.
Mariah, how did you determine, because you must have gone through that same process of determining that spec?
Yeah, so I basically just asked the people in the hospital what their flow rates were. And the answer was basically, we don't know, it just kind of happens, which was, I thought, pretty scary, but that's how it goes in these kind of hospitals. I think in my research, I did a lot of calculations, and I think I calculated it by seeing what the flow rates were that they gave. The trouble was that a flow rate that I didn't think was that high was still faster than I thought. So it was still pretty difficult to warm even at low flow rates because the fluid itself is still moving pretty fast. Yeah, but I definitely think it is what I was working on personally was not like a combat zone flow rate where you need to like pump blood into someone immediately. The hospital that I was working with wanted to use it during brain surgery, in case patients were weaker during the brain surgery, and especially because in Nepal it kind of gets cold in the winter, and houses aren't really insulated well, and hospitals especially not. So when it was winter, we would like sit in our office with our coats on and like blankets because the house wouldn't retain any heat, and we'd go outside to get warm again. And in these hospitals, it's kind of the same case. Like in the winter, the doctors are like walking around in coats because there isn't really like it gets pretty cold. So it was mainly also used for that we can't keep these people in this really cold environment. And if they're already kind of like hypothermic, if we also give them cold blood, that won't really work.
Do you see that as a kind of like a make or break on this IV fluid warmer and being able to be deployed in different climates easily, or like zones where climate control is not necessarily?
I think it's a bit important because the hospital I was working with, like in the winter, it was like really cold inside the hospital, and in the summer it was really warm inside of the hospital. But on the other hand, if people would need a blood transfer in the ICU, they'd probably be okay because that was the only climate controlled room in the entire like hospital.
Okay.
So that was the only place where they had AC, for example. So I do think it's important that it works when it's like a little bit colder, but I wouldn't say that is something I would worry about too much. I would just try to figure it out in your own climate before trying to see how we can translate it to other climates.
John, in your research, most infusions, I feel rusty on this, blood transfusions, and also if they're administering IV, they just hang a bag on the stand, right, and then connect it to the needle and then let gravity drive that flow, right?
Yeah,
or do they usually have a pump?
My understanding is that majority of the blood transfusions or blood product transfusions are done without a fluid warmer.
I have a thing here. Sorry, I can't see myself, so I don't know what I'm showing. This is in Nepal what they would regulate the flow with. It's basically just a little wheel that you can like make it lighter or make it slower. And there was really no other way that they controlled the flow in these hospitals.
So
I mean, I think that's true.
They never actually like
a large hospital in the States
Okay.
too. I think that's just how infusions are and transfusions.
And those are probably for transfusions that last over like 4-hour period or something like that. Maybe.
Yeah, well, I've seen transfusions where it was like really necessary that people got blood and they would just squeeze the bag.
Yeah.
That was
Right, and that's worst case scenario for your fluid warmer, right? Because then you've got to heat all of that at that flow rate. Yeah. Do you guys have any idea of, you were talking about some FDA regulations that you were following? Is that some of the information in that report?
I think in the report I looked up like what it was exactly. It might be a little bit outdated. It's like 2 years old at this point. Well, it's been more than 2 years since I looked that up. But I think I had like the number of the document somewhere.
Okay.
It should be in there. Oh yeah, it's a document called the requirements from the standard specification and their tests, blah, blah, blah. It's called the standard specification for blood/intravenous fluid/irrigation fluid warmers, F2172 stripe 02.
Those are kind of like my technical questions. Do I have some time here?
I did have one comment for John L. It'll take like 10 seconds. And this actually might apply to John O as well. But it seems like maybe both of you are kind of ideating along the lines of wrapping a coil around a heating element. Yeah, so one thing I would keep in mind while you are thinking through that is the length of line that usually comes on the end of an IV bag, because especially with your design, John L, I could see you running out of tubing.
Okay. Do you know the typical length of it?
I think you know, but I think you'll need to do some research. But just in my experience, like when we did disposables at my last company, we did a lot of blood bagging and disposables and tubing linked to that, and there tend to be standard lengths. So yeah, I would just try to figure that out and then make sure that's something you're considering. It's not like there's an infinite spool attached to your bag.
Yeah, right, because it's got too long of a line as well, right? Well, I guess you only have so long of a line of IV anyways. Okay.
Yeah, I'm just saying, like, your scheme of stacking like 4 in a row, you probably don't have enough line to like actually wrap it around 4 heating elements.
Okay.
Yeah, definitely keep in mind that it's also still attached to the patient as well. And the bag is typically like, I think about 1 meter above the patient. And then you have to wrap it around something, and then it has to attach to the patient who is in a bed next to a pole who is moving around. So it needs to have enough line that they can still comfortably lay in the bed.
And you have to make it easy for the person to load, and make sure that it doesn't like unspool to like some sort of fixture at the end where you like kind of snap the tube into place to hold it. Or maybe you have some sort of casing that like has ridges for the tubing to fall into. Also, so that you get some sort of uniformity in terms of how many coils per element, because if one operator coils it 5 times and one operator coils it 20, like I think it's good to kind of design tubing paths into stuff like this. Like in our devices at my last company, it's very clear paths, usually like indicated with color, and then like little snap places to make sure that you're like loading a set correctly.
All right, so I'll just run through a few things here. Thank you again for your amazing entries, everyone, and for attending this session. I think it's always great to talk in a group setting and definitely get some of this experienced insight into these projects. So I saw John O had updated. It looks like you reorganized your page a little bit based on our last mentor session. So awesome work there. Something that I recommend sort of over and over again in these sessions is to think about that judging criteria that I copy and pasted into the the mentor session invite. That's in the official rules, and that's really making it, organizing your page so that the sort of the questions to those criteria are answered clearly, and it doesn't hurt basically to make it extra obvious where to find that information on your page, because that is what the judges are looking for. And so I recommend to everyone to either reorganize your information or create an extra log where you can essentially copy and paste what you have in that format where you are addressing each criteria. Will help, just make everything extra obvious how you're addressing all of that. And that can be found in the official rules, which I'm going to share my screen here so that we know sometimes the rules can be tricky to navigate. All right, so on the contest page, which you can find by going to contests and then it's Supply Frame Design Lab Hackaday Prize. If you go down the details, so just on the page, contest details, the official rules are right here. These same rules can be found on the landing page, prize.supplyframe.com. Under criteria, so if you scroll down, entry round criteria, this is important to note. This is what, will make sure you qualify when entries are reviewed right after August 31st, when the entry period closes. So something important to note there. There's specific number, minimum number of logs. I think most of you have this covered, if I'm not mistaken, as far as, at least one image, and the logs, the 4 project logs. But definitely make sure you have those covered. And then it's never, too early to start thinking about the final round requirements, and sort of get ahead of the game there. For if you do make it to the final round, this is what will be required by the final judging in October. So once finalists are announced at the beginning of September, they have about 1 month left to sort of polish up their projects, and then final judging will happen in October. Further down, you'll find the judging criteria here for the entry round, and then again what I copy and pasted in the email for the final round. The entry round are essentially vaguer versions of the final round criteria. So again, I think it's great to look at the final round info, because why not, do that as soon as possible. And so that's what I would recommend. And part of that, when we talk about benchmark, which is how sort of your idea compares to what's already available or what's already out there, whether it's more affordable or easier to construct or more energy efficient or whatnot. I think that's definitely something that helps, make entries more competitive. So something to consider: how can you illustrate or even write about, how yours compares to what's already out there, and sort of do a check on sort of competitive analysis. If we go back to the details, the page, again, on the challenges, you'll find, let's go to the field ready, the Mylene's PDF. It was uploaded a little further into the competition. And so it's right here, but I can also send you all the link to the same mentor session email. And that will have her thesis, since that came up for 2 of your projects here. And other than that, wanted to mention a few dates. We'll be announcing the winners of the Bootstrap Community Vote Award tomorrow, the 17th. It's like the 17th is coming up. The 17th. So if you guys were in the running for that, you should receive a notification if you will be getting the $500 Bootstrap funding. So that's exciting. Also, if you're not receiving the monthly Hackaday Prize newsletter, please shoot an email back to prize@hackaday.com, because that should be going out to everyone. Each month we update people with the mentor sessions, the important dates, resources, links to the latest YouTube videos we've done, interviews with each nonprofit, things like that. We have heard that some people, they found it in their spam. So check your spam, because it goes out through MailChimp. So unfortunately, we can't always control where that goes into everyone's inbox. So, but feel free to always reach out with any, follow-up questions to this session or to anything to that email. It'll be me or one of my colleagues getting back to you. And, we want to provide as many resources as we can for you all to succeed. So thank you again. If anyone has any last quick comments, you're welcome to shout them out. Otherwise, hope you all have a great rest of your week. And yeah, we really appreciate you being here. And thanks again to our mentors for their time today.
Good luck and good work. It's cool to see what everyone's pulling together in their spare time, and it's cool to see how active the community around Hackaday is.